illustrate. So this is a 1 mass from 4 height, and this is a 2 mass from 1 height. Okay, so we're talking about a 2 velocity, a 1 mass going 2 velocity, a 2 mass going 1 velocity. Now my claim is it's exactly the same energy, same capacity to do work. Kinetic energy says this has twice as much energy, the lighter object. All right, now he's debunking my claim, and yet he didn't put the camera in the same place. So I'm claiming it's the same energy, so the camera should be in exactly the same place because it's supposed to be the same exact stretch of the rubber band. But obviously, if you look at look how much dark space is up here versus here. I mean, it's a huge parallax problem. I mean, the camera is not only...
For fuck's sake, dude, I have showed you everything about the parallax problem. I've explained everything. I've evidentially proven there is no parallax problem. I put it in the beginning of the video. I've timestamped it, yet you don't give a fuck about it. You don't pay it any attention to what I'm bloody explaining. You fucking pathetic evidence denier.
A little blob of clay or something, some way to get a more perfect, a better measurement than this visual one. You can distort by just changing the angle of the camera. You can get a completely different number. The same thing will look completely different depending on the angle. So he could just show us that. He could just show us in one spot, and then he could show us, well, look, if I look at it this way, it looks like 41 centimeters. If I look at it this way, it's 43 centimeters. So, I mean, it's just such bullshit.
That's exactly what I've done, you fucking asshole. You don't pay any attention. What you're saying, I've done exactly that. Go watch the video again and watch me doing it. When I view it from one spot and I view it from another spot, you see exactly the same number. This is to demonstrate whether or not there is a parallax problem. I'm going to drop the 1 mass each time from the 4 height position. And first I'm going to place the camera over here. Then we're going to see wherever the rubber band comes. We're going to see a number, let's say it comes over here. So that's going to be at an angle. We're going to read the number from the perspective of the camera. Then I'm going to move the camera to the left. I'm going to drop it once again and see whether or not we will read the same number on the ruler. And if those are the same, if the number that you read over here is the same as the number as you read over here, then there is no parallax problem, right? So here we go. Let's first start here. 4 height. Okay, there you go. Now moving it to the left. Do it again. Okay. Maybe a little bit further now. Third trial. Okay, that's it. Here, the maximum stretch was in the center of the camera lens, and it's aligned with 33.2. Then I moved the camera more to the left, so now the maximum stretch is taking place more to the right of the camera. So we're viewing it from an angle. And what we see, it's only 1 millimeter in difference. It's aligned with 33.3. And then I moved the camera even more to the left, so now the event is taking place almost to the outer right in the corner of the camera lens. And what do we see? It still is around 33.3. So there is barely any parallax problem. So whether I move the camera to the left or to the right, the numbers will be seen exactly the same way. It will always be the same number. There is no parallax problem.